Okay, good morning, algebra students. Today we're going to continue solving linear equations. And today the method we're going to use is elimination. Remember, there are three different methods. They're graphing, substitution, and elimination. So this is the last method that we will learn. All right, so this is sometimes called the addition method, elimination. So a system of two equations with two variables can be solved by adding the two equations together so that one of the variables is eliminated. So you're going to add the two equations together, trying to eliminate one of the variables. Then you're going to solve for the resulting equation for the remaining variable, and then you substitute this variable back into one of the original equations and solve for the other one. Again, you're looking for an ordered pair that satisfies both equations. All right, so let's start with this problem. So we're going to solve this system, and what we're going to do is we're going to line this equation up like we're subtracting. So I take the first equation and I write it down. And then I take the second equation and I write it right underneath it. And I'm lining up the y values, the x values, and the constant. So now all I have to do is, because I have these x's and y's, I'm going to add this equation together. So I'm going to add the negative 2x plus the positive 2x, and when I do that, it cancels because a negative 2 plus a positive 2 makes 0. Then I add the y's together. I have 3y plus 1y, that makes 4y. And then I add 11 and 1, that makes 12. Then I can solve for y, and I see that y is going to be equal to 3. Then I take the 3 and I can substitute it back into either of these equations to solve for x. So let's do that. So I'll just do the first one, negative 2 times x, times x, plus 3 times 3. So the y is 3. Does that equal 11? So then I have negative 2x plus 9 is equal to 11. Then I subtract 9 from both sides. So I get negative 2x is equal to 2. So then I know that x is negative 1. So my answer is an ordered pair, negative 1, 3, and this is where those two lines intersect if you graph them. All right, let's try another one. All right, so example number 2, let's write it down. We have 6a plus 7b equals negative 15. And I'm going to add that equation to 6a minus 2b equals 12. Now I have a little bit of a problem because when I add these two together, I'm going to get 12, and I'm not going to have them eliminated. So again, you're lining up your variables. You have the a's here, the b's there, and your constants. The goal is to be able to add these equations together and eliminate one of the variables. Well, what I can do here is I can take this entire equation, or the top one, and I can multiply it by a negative 1. So if I multiply the bottom equation by a negative 1, or the top one, then I will get a negative 6, and then I can eliminate. So let me do that. Let's just rewrite the top one, 6a plus 7b. And it doesn't matter which one you multiply by negative 1. I just chose the bottom one. So now I'm going to multiply this entire equation by a negative 1. Multiply that by a negative 1, so you get positive 2b. And then multiply that by a negative 1, and you get negative 12. Now I can add these equations together, and this will be eliminated, the a variable, and then I can solve for b. So I get 9b equals negative 27. Divide by 9, and I get b is equal to a negative 3. So now I can take what b is, and I can substitute it back into either one of these equations to get a. So let's do that. So I'm going to do 6a plus 7 times negative 3 equals negative 15. So I'd get 6a minus 21 is equal to negative 15. Then I add 21. So I'd get 6a is equal to 6, which means a is equal to 1. So the solution to this system is an ordered pair that is 1, negative 3. And that's the point of intersection of those two equations. All right, we have two more examples. They get a little more complicated, so let's look at them. Okay, so next we have two equations. So the first thing you want to do is line them up. So 2x minus 3y is equal to 4. And then we have x plus 4y is equal to a negative 9. Now my goal is to be able to add these equations together so that one of the variables is eliminated. Well, none of them are the same. So what I can do then is I can use multiplication to change one of the equations so that when I add it to the other equation, one of the variables will be eliminated. So what I'm going to do here is I'm going to multiply the bottom equation by a negative 2, because if I do that, then the x's, when I add them together, they will be eliminated. So I'm going to multiply this bottom equation by a negative 2. And I'm going to put that over here. So let me rewrite the top equation. Now remember, your x's and your y's and your constants all have to be lined up in order. So then I'm going to multiply the negative 2 times x. So I have a negative 2x. Then I multiply the negative 2 times the 4, I get negative 8y. And then the negative 2 times the negative 9 to get 18. Now I'm going to add, you can see that if I add these two together, they're eliminated, which is my goal. So that's eliminated, and now I have a negative 11y is equal to 22. If I divide by a negative 11, I get y is equal to negative 2. Then I can take this and substitute it back into one of the equations. So I'll do that to the first one. 2x minus 3 times negative 2 is equal to 4. And you know the drill by now, so you get a positive 6. Then you subtract 6. Then you get 2x is equal to negative 2. Then you divide by 2, so x is equal to negative 1. So my solution to this particular system is an ordered pair, negative 1, negative 2, and that is the point where these two equations intersect. All right, we have one more. Okay, example 4. This is our last example for today. So the first thing you want to do is write down the equations one on top of the other. So you have 4x minus 5y equals 6 on the bottom, and then 3x minus 8y equals 13 on the top. Again, the goal is to eliminate one of the variables, and we're going to add the equations together to eliminate. Well, first, before I can add, I've got to try and make one of the variables disappear. So that means they have to have the same coefficient but opposite signs. The same coefficient, the same number that's in front of the variable, but opposite signs. So if I look here at the 3 and the 4, or the 8 and the 5, right? I can multiply to try and get the x's to be 12, maybe. So what can I multiply this equation by to make this 12, and this one to be 12? But then I not only want them to be 12, but I want it to be either positive 12 and negative 12 because I want to add these together to eliminate. The other thing I can do is I can multiply by this one by 5 to get 40, and this one by 8 to get 40 here. So I can choose what I do. Well, I'm going to choose to work on the x's and eliminate the x. So what I'm going to do is I'm going to multiply this equation on the top by 4, the entire thing, because I'm going to get a 12 for my x coefficient. And then on the bottom, I'm going to multiply the bottom one by a negative 3, so that I end up getting a negative 12. So I'm going to do that. So watch this. On the top, I do 4 times 3, which is 12x. And then I do 4 times the negative 8, which is negative 32y, equals, and then I do 4 times 13. 4 times 3 is 12, so I get 52. Then this equation I'm going to multiply by a negative 3, so I get a negative 12x. And that was my goal, is to be able to get one of these variables to have their coefficients when I add them together to make 0. Then I'm going to do the negative 3 times the negative 5, which makes a positive 15y. And then I do a negative 3 times 6, so I'd get a negative 18. Now I'm going to add the two equations together. Again, my x's are lined up, my y's are lined up, and my coefficients. So that is going to be eliminated. Negative 32 plus 15 is negative 17. Yes. Negative 17y. And then equals, if I add these together, I get 12 minus 8 is 4. So I get 34. Then divide both sides by negative 17. So I get y is equal to a negative 2. Now I take that and substitute it back into the original equation. So I'll just do 3x minus 8 times negative 2 equals 13. So 3x plus 16 equals 13. Subtract 16. And I get 3x is equal to negative 3, which means x is equal to negative 1. So my ordered pair, my solution to this equation, this systems of equation, would be negative 1, negative 2. And that would be the ordered pair where those two equations intersect. Okay, well that's it. I will give you an assignment now for you to do for homework. And hopefully this made sense to you. And I will certainly help you in class. So thanks.